started. Hello, everyone. My name is Edwin Jaquez or Eddie. I'm currently the computer science community coach with the K-12 team at Cornell Tech. And today we're going to launch into the topic of teaching AI in the middle school environment with computer science, specifically using a tool which may or may not be familiar to some of the folks attending, but we use Google's Teachable machine, and we're going to learn a little bit more about how we use that to infuse middle school with some machine learning and AI. So let's see, hopefully I don't get any tech issues. So here's a quick overview of our team. Diane Levitt, who's on the call and in the chat. Hi, Diane. She is our senior director. I work under her and Meg Ray, who's currently our director of the Equity Lab. And here's a couple of folks from our team: Felix Alberto, who's also my colleague and also community coach working with one of our partner schools currently. And the rest of our team: Sophie Lanches, who does all the coordinating on all the behind the scenes work, as well as Nancy, and then Niti, who's our designer in residence and helps us with a lot of the visuals and a lot of the things that we create. And our session today is around emerging tech, specifically with the use of AI, answering the question of how do we incorporate teaching technologies like AI into the CS class. And here's some of our objectives. We're going to learn a little bit on how to incorporate it using Google's Teachable machine. I'll drop the link to the Teachable machine in a moment as well, just if folks want to have a separate tab open and tinker with it. And then how do you engage students with hands-on activities? We're going to walk through 2 activities and then talk a little bit about how to make it accessible for young learners. Before we launch, I want to first define what AI is, or at least how I'm thinking of AI, because as you know, everyone sort of has been tossing up AI and defining it based on what their work within AI is. And so I sort of wanted to zoom us out a little bit and look at what is AI, and then what are all the other components that live within it or that are encompassed by it. And so hopefully this visual helps. We have artificial intelligence. Within that, we have machine learning, which is what we'll dive a little bit into. And then we have deep learning, which we will not talk about today, but it is within the machine learning as well. Artificial intelligence is the technology that enables machines to mimic human actions and decision-making processes. Machine learning is the method by which these machines improve their performance based on the data and experience that we provided. And so today's session, we're going to be focusing primarily on machine learning, but I will preview a little bit or just one example of AI, just so we can sort of compare and contrast the difference between AI as the machine that mimics and makes decisions versus the machine that we are training and providing data for. And why does this matter? Well, I think AI, as we know, has been the keyword this year, actually for the last 2 years. But it is already in the hands of our students, and we want to make sure that we're preparing them for the future by providing them ways and connecting them to tech-driven careers to help them understand the tech that they are already interacting with. So hopefully my sound works when I play this, so I'm sharing my screen. So here's a quick example of generative AI. Now, I could have opened the tab and just showed you guys how to, prompt ChatGPT, right? I think a lot of us have already experienced some sort of interaction with these language models, like ChatGPT or maybe Gemini on Google. But I recently took a course over the summer, which helped me sort of see the big picture on how and what else can AI generate. And I was fascinated by music. I play the guitar in my spare time. I don't know how to read music yet, but I am taking classes. I'm like really into it. In my previous job, I used to DJ all the school dances at the school I worked at. So music has always been a part of me. Definitely now I can bring it into the work that I'm doing and connecting with AI. So there's this tool called Suno, and I'm going to provide y'all with a clip of a song that I generated using AI with this site called Suno. And much like these large language models, you do have to prompt the AI, and the AI is it works off of the data that it's already been trained on. So these models are trained on large data sets of music. It learns patterns. It can identify melodies, rhythms, and harmony. And then the prompt that you provide it is via text. And it selects the genre, the styles, and you get to prompt and generate the specific type of music that you want as the output. The audio generation is sort of where the toss-up is. It's kind of like a roulette. You don't really know what's going to happen because the AI is going to interpret the information you're feeding it, and then it'll spit out or give you an output. And so it processes the prompt, it synthesizes the music, it usually creates very unique melodies, and then you can continue to refine it until you get your desired outcome. And so you continue to iterate and make adjustments based on the feedback. And Suno is free to use. You can create up to 5 free songs a month. If you pay for it, there's a subscription where you can make up to 2,500 songs a month. It's about $10. So super fascinating if you're into music like me. I'm gonna play a clip. Hopefully you guys can hear it, and then we're gonna move right on. Y'all hear it.
J'ai oublié d'avoir ton visage, tout est flou maintenant. La nuit était belle, mais c'est passé vraiment. On s'est vu quand, franchement je me souviens plus trop. On s'est dit quoi, la nuit était belle, mais ça vaut quoi? Dis-moi qu'est passé, j'ai oublié, c'est pas ta faute. On s'est vu quand, maintenant c'est flou, tout se mélange dans ma tête.
So I do not speak French. And if you notice, this song is in French. I first wrote it in Spanish with the help of ChatGPT, and then I sort of had it translate, and then I tweaked it so that some of the chorus could rhyme, and then I had some of my French-speaking friends read it before I had the AI prompt it. And so the prompts that I gave it was female vocal, Afrobeat, R&B, amapiano, jungle, chant, Afro, reggae, melodic, soft, feminine, Arabic drums, and upbeat. And that's what it gave me. So it's pretty fascinating, but I wanted to preview this. I just see the comments, you weren't expecting lyrics. Yeah, so the software itself can generate lyrics. It's usually not that good. So yeah, there's a lot of behind the scenes work, right? Like you still have to decompose and think about or have at least some basic knowledge in songwriting. What is a verse? What is a chorus? Because you have to specify those things in order for the AI to understand exactly which component of the song it needs to generate and what melody it should provide for that specific beat. So lots of really cool things there. But again, we're gonna move us right along. If you're interested in learning a little bit more about that, definitely reach out to me. So there are 3 parts to AI. It's the data set, the learning algorithm, and then the predictions that it makes based on these. So the data set is a collection of examples that the model uses, and it could be pretty much anything, right? We'll see some examples coming up. The algorithm is the brain. It finds essentially the data. It looks at the data, finds patterns, and then based on that, it will make predictions. And then you can continue to refine and teach it, right? I'm quoting it. Quoting teaching here, because you are essentially feeding it data and programming. And I think when I say teaching, it kind of humanizes the AI a little. So I don't like to talk about it that way. Machine learning uses this data to make classifications. And so to classify simply means to arrange or put things into groups or categories based on their qualities and characteristics. And some of this is used in the real world, such as handwriting detection software and tools. So like in the post office, when you mail a letter and you handwrite the address, it is fed through a machine that then interprets your handwriting, and the computer will then scan it and sort it to be sent to its final destination. Same with facial recognition. All of our phones, our cameras currently can recognize faces, which allow you to either overlay a face with a filter, or you can make specific adjustments to people in the photo that you're going to take. And most of that technology is already built into our devices and a lot of the software that we use. Here's an example of sorting data. And so in order to teach the machine to sort fruits, for example, we must give it labeled examples, and we call this the training data. right? So here we have bananas, apple, pear, watermelons, right? And these are all different fruits. And we as humans can easily identify and sort these. If I were to ask the folks in the room right now to sort these, maybe a subset of folks will sort them based on color, maybe texture, maybe taste. And so the computer does not know the colors or the taste or the textures yet, unless we specify and give it that information based on the label, right? So I could, if I wanted to further refine this, this data set, I could either pick one fruit, give the information, more data samples of what that fruit could look like, and then continue to program it so that the machine becomes better at sorting and it won't confuse a pineapple for a banana, for example. So here's a really good example of just like a visual overview. So here we have a couple of different images of bananas. So we can see that these are bananas, but the computer may understand that, like, if I give it or show it a picture of a yellow lemon, a very yellow lemon, that might think, oh, it's yellow, so it may be a banana. But because of either the shape, or it tries to compare this specific image to the images that it's already aware of, or that's in its data set, it may also say, no, this is not a banana, even though it may correlate it with the color yellow. And we'll see some more examples of what that looks like. So Google also has an incredible free app called Quick Draw, which students love. And for this, I am actually going to open a new tab. So let's see how I can share that tab with y'all. Here we go. So Google has Quick Draw, and the way that this works, I'm just going to model it really quickly. You get a prompt. So now I have to draw a microwave oven in under 20 seconds. Oh man, it's going to be interesting. I'm doing this live.
I see computer keyboard, or camera, or sleeping bag. I see pillow. I see backpack. Oh, I know. It's microwave oven.
Okay, so it got it. But I can continue, right? And now it's asking me to draw ice cream. So let's see.
I see green bean.
And as I'm doing this,
oh, I know. It's ice cream.
It's predicting at the bottom. You guys can sort of hear it making those predictions as I draw the image. And so I'm going to show you.
Or square. I see cup, or dishwasher, or shoe. Oh, I know.
All right. I'm kind of too good at this game. So let's get out because I want to show you the data. So the way that this works is every time I draw, yes, Quick Draw is addictive. Every time I draw, it is interpreting, the machine is taking that image that I'm drawing and it's interpreting it or trying to associate it to images that it's in its data set. So if we look at banana, for example, these are all of the images. Oh, wait, you guys can't see this. Sorry. There we go. So if we look at banana, in its data set, and I keep scrolling down, these are all of the images of bananas that people have contributed to Quick Draw. So this is, you know, anytime you get that prompt to draw a banana and you start to draw that shape, it'll try to make connections to any of the shapes that are in this data set, which I think is fascinating. And it doesn't just do that with bananas, obviously, it'll do that with any of the other prompts. And there's tons and tons of other images here. So pretty cool. If you haven't played around with it, definitely check it out. We sort of preface machine learning with students by having them go on Quick Draw, and it's sort of, you know, they're having fun, they're not really understanding, but then as, you know, we give them some time to tinker and play with it, then we go into more in-depth conversations around why do you think that the software knows that when you're drawing, or, you know, maybe you got something wrong, like why do you think that is? What shape are you drawing that the machine may know, right? So for the microwave example that I just did live, it was guessing as I was making the box, it thought TV, right? So it was already making predictions based on the shapes that I was giving it. And the more refined that my drawing got, the closer it got to the end result. So yeah, good point, Diane. That is abstraction, which the machine is doing. And it is just programmed to do that. So it's pretty cool. So we're going to transition us to Google's Teachable machine. Again, another Google product, which we use. And we use it because it's user-friendly. It allows for visual interactive learning. It's ideal for middle school students. We've led sessions with over 100 students on our campus. using Teachable Machine over the past couple of years to lean them into the world of AI and understand how AI works on the back end by allowing them a hands-on experience in programming their own machine. And it is free. It is a browser-based tool, so there's no downloading that needs to happen. I know for a lot of teachers, that's a huge concern of, maybe you're using Chromebooks and you need to download a specific software or tool. This does not require any of that. This is completely on the web. And the way that it works is, actually, I'll probably just do a live demo, which is better than going through these slides. Just bear with me one moment. Now, it may conflict with my camera, so I might not be able to do the live demo because I'm also streaming. And Teachable Machine will need access to my camera in order for me to train the machine. But I'll show you how it works. So let's say I wanted to create a machine that could sort or identify whether I am giving it a thumbs up or a thumbs down. And this is actually the first activity that we provide for students. And so we have these things here called class or classifiers. And so these are just the categories of things that we want to go through or we want the machine to interpret. So I'm going to say thumbs up, and we're going to do thumbs down. And let's see, maybe, oh, it works, cool. So thumbs up. As I hold my thumb up, I'm going to sort of get out of the way so that the machine doesn't think that my face is a thumb. And I'm just going to click down on where it says hold to record, and I'm going to capture my thumb in a bunch of different ways just so that the machine can interpret what thumbs up looks like. So you'll notice as I keep this button pressed down, those sample images are increasing. So now I have 148 image samples to identify thumbs up. I'm going to do the same for thumbs down. Again, I'll get out the way. It's a little hard to do one-handed, by the way. But while this is happening, students are highly engaged. They're having tons of fun. And they also have an opportunity to debug. So there may be issues that come up as we train our model. And so the program is called Teachable Machine. I'll actually drop the link in the chat. Sorry about that. Give me 1 second. There we go. All right, so while this is happening, it is a bit of a slow process. So you'll notice right now it's training the machine on my data. It takes a while. This teaches students patience, which a lot of us, even as adults, don't have. And just so y'all know, because you didn't see this, but I just got a page unresponsive pop up. So let's see, hopefully it doesn't freeze out on me. Oh man, come on, computer. There we go. Okay. So now it is training. Yes, Diane. It is taking in all of that data that I just trained it. So now the computer, or this machine rather, should know that a thumbs up could look like all of those different versions of the images. You'll see now I got this pop-up that says, don't switch tabs. You must leave the tab open in order to train the model. So I can't switch tabs right now. My hands are tied up as we wait. And again, I'm sorry. This is kind of hard to replicate or to have slides for. Sort of got to do it live. And you'll notice that it's counting up as it's training. And then what we'll do over here where it says preview is once the machine has been trained on my data, I can then test it. And this is where the fun happens. So I'm curious to see if it will interpret my thumb as thumbs up and thumbs down. Let's see. I do not want to export the model right now. So, all right. So you'll see that this data point down here is kind of just jumping up and down. It's trying to figure out if my face is thumbs up and thumbs down. And for whatever reason, my AI has some bias and it thinks that my face looks like a thumbs down, whatever. So I'm gonna see. If I put thumbs down, what happens? I gotta get out the way. All right, so thumbs down and thumbs up. Now, what I would do to go a step further is, you notice that if I get out of the situation, out of the screen, it is sort of leaning towards the thumbs down. So I would probably go and add another class, and I would just call it no thumb. And then I would train that classifier with a bunch of images that do not include any pictures of my thumb. And to Will's point in the comment, yes, it may be interpreting the sleeve or the little bit of red in my shirt as part of the thumbs down, because if you notice in my training data, it has a little bit of that red in the sleeve in the images. So good observation. And those are things that we can bring up with students as they're working to debug why their bot may or may not be interpreting their data the way that they desire that outcome to be. So a really fun way to engage students and to have them sort of understand that the more data, the better. And we usually have them work in pairs for that activity, just so that the data sample has variations of different thumbs. You'll run into some interesting situations where you get different skin tones not being recognized. And those are really good opportunities to have conversations around AI and bias in AI. I'm going to pivot us back to the slides for just a second. So this was the activity that I just walked us through. This is activity 1. And I have all of these resources, which I'll also share with folks once I get to the end. I'll drop the link to the slideshow. So you can have access to all of this as well. Here's a potential extension to this activity, where once students have been able to sort their thumbs up and thumbs down, we then ask them to continue programming their machine to recognize different expressions with their hands. So it could be okay, it could be a wave, a hand wave, or the heart, or the peace sign, etc. Let me just walk this through. And I have all of the steps to how to get started and how to get through all those steps that I just modeled for y'all. One of the ways that I like to make connections for students anytime that I'm walking them through any lesson or activity is connecting them to the real world and ways that they would be able to interact or see this sort of technology in the real world. And I know there's a lot of tools for folks who do American Sign Language or interpreting using body movements in video gaming design. A lot of students also use hand movements. Specifically, I know for VR, my nephew has a Meta headset, which uses a lot of the hand motions to make predictions for the movements in the games that he plays. So there's a lot of ways that students are already engaging with this sort of technology. This is just another way for them to be on the back end and sort of create versus consume. And I'm going to move us right along to the second activity. And this one's an emotion detector. So this one, if I were to categorize the first activity and this activity, this would be like a level 2. So it's a little bit more involved. And you'll see why in just a second. The goal for this activity is to train a model to recognize different emotions based on facial expressions. So for this model, students would create different classifiers for the different emotions that we want their machines to interpret. I usually like to create parameters so that students aren't creating more than what is needed, right? So, and also to sort of guide them through the activity. So I may provide them with the specific emotions that I want them to program their machine to determine. Otherwise, you're going to get a bunch of different categories like happiness, sadness, depressed, a little happy, right? And so you want to sort of limit that amount just so that everyone's on the same playing field. And then same process, they would label these emotions, they would capture all this data, and then they would train the model, they would preview it, they would continue to refine. One of the ways that this activity can be extended is with masks, and having students create masks that show different emotions and see if the machine will tell the difference between a human face and a mask. And then another layer of this is to have the entire class go around and test each other's machines to see if other folks' machines will read their emotions and their masks. That's a really good opportunity to identify bias in the machine that students have created. Something that has happened when we've led these sessions is maybe I created a machine and my colleague created a machine, and maybe my colleague has blue eyes, blonde hair, which I don't have, and my machine might have a bias towards reading my facial expressions differently and identifying my characteristics versus my colleagues, and vice versa, right? So that's a really good opportunity for students to talk about why that is. How do we fix that? Where can we see that as being a problem in the real world, etc. So I know I've been bringing up real world applications. So here are some examples. So for gesture recognition, like I said before, it's used in gaming, accessibility tools, and customer service. In the emotion recognition, it's often used in healthcare, in marketing campaigns as well. So I don't know if a lot of folks know this, but there's ways that certain tools on your personal devices, or even when you're out at a store, they're capturing a lot of the images of our expressions, especially when we're doing checkout. There's cameras everywhere, at the airport, etc. And so all of this technology is already in use everywhere that we go, and user design as well. So they capture all this data, and then they create marketing campaigns for us that are very targeted and specific to things that either make us happy or sad, etc. And then connection to from classroom to career. So this also is a good way to introduce students to real world applications and spark some more interest in STEM education and STEM careers. I want to also talk a little bit about the ethical considerations with AI. So I know I've been bringing up bias, but I'm also going to talk a little bit about privacy. So we all know that there is bias in AI, and AI can reflect these biases based on the data set, as you just saw earlier. For example, so if there's a lack of diversity in the images, it could lead to misidentification. So in like the example I gave earlier, where my colleague and I may have created different machines, and my machine may have a preference over darker skin versus lighter skin, or vice versa, that is a opportunity to talk about that. So one of the reflection questions that I always ask students is, how do we ensure that AI benefits everyone, right? Because if only I'm programming my machine, how do I make sure that my machine is actually something that everyone can use and that it benefits all of us? We could also, bigger picture, a lot of AI tools that exist out there are being used by companies to determine our insurance rates. They're, whether you qualify for certain scholarship opportunities, or, loans, etc. And so talking about how AI is being used in the real world could be a really good segue for students to make connections in the classroom and have a deeper level understanding of how an appreciation for why and how they should be interacting with AI, both in and outside of school, which leads us to privacy. So discussing with students the importance of data privacy and responsible AI usage is really important. I know I opened up our session today with music generation. I also have another example of something that I created, which is unethical. And I'll save that towards the end after I get through all these slides. But having conversations with students and exposing them to like, hey, here's a way to use it the right way, right? Like the ethical way. And also showing them examples of unethical use and some of the consequences that unethical use of AI can lead to is really valuable. So it's not just all the good. We should also bring up some of the bad. Here are some examples of AI bias. So we'll see racism. I think that's the most explicit one, but there's also sexism, ageism, and ableism. a lot of these AI tools that are being made are not taking everyone into consideration when they're being designed or when they're being fed the data. And so it is really important that students understand that the data is the most important thing. And the more diverse that the data can be, the better their machines will get over time. So here's some ethical guiding questions for us when we're discussing bias in AI. And I'll ask this to the group, and you can feel free to drop your responses in the chat. But what do you think would happen if an AI tool was only trained on certain types of images, right? So if it had more photos of light folks versus darker tones. If you can think of ways that AI may unintentionally reinforce stereotypes, I can give you an example. But what if an AI often associates certain jobs or activities with specific genders? Or how could we make an AI system more fair and accurate for everyone? So what kinds of data would we need, right? And giving students the opportunity to think about these things without us giving them the answer, I think is really powerful. One example of an AI tool that, I mean, it's so funny because a couple of years ago, I was at an airport, I think it was in Sweden, and I went to use the faucet in the airport, and like the faucet would not turn on for me, but it was turning on for my cousin who's of lighter skin. And so there's like things out there where like there's sensors built into things that, you know, the data is not necessarily leaning towards a more equitable data set, right? So I don't know if that specific manufacturer at that time didn't have enough dark folks turning on the data to make sure that the faucet would turn on with darker skin, right? So that's one example, but there's so many more. When we pivot over to privacy, here's a couple of questions that can help us guide some of the student thinking. So when we share our photos or personal information to train AI, who do you think might have access to that data and how might it be used? Right? So we took a little preview into QuickDraw and we saw that there's tons of data. However, in that main page, when you go to QuickDraw, they explicitly tell you that this is an open source way of capturing images. They are going to use this data, right? Like, so QuickDraw is letting the user know right off the bat, hey, we're gonna take your drawing and we're gonna use it to make our tool better at predicting. But there may be other instances where that information and that permission is not made clear. And so asking students to think about that. Imagine you're using an AI that learns from your own pictures. How would you feel if those photos were shared publicly without your permission? And what guidelines or rules could help protect people's privacy when using AI in the classroom, right? So, and I would even further that question expanded to not just the classroom, but in school. There have been so many instances of AI being used in ways that are unethical that I think are really important to talk about, because those situations don't necessarily happen in the classroom. We have some student reflection questions too that I'm going to provide as well. How could the skills you learned with teachable machines be used to solve real world problems? When we think of this type of tech, how do you make sure that it's safe for everyone? If you had to tell a friend who's never heard of teachable machine, what would you say it is? And you'd be fascinated by those responses that you get. And here's some questions for us. And I know I've been sort of speeding through some of this just because I want to give us some time for some Q&A. But how could these activities be adapted for your classroom? What real world problems could these skills help address? And then what ethical considerations are important when developing and using AI as well? And I'm just going to take a moment while I let you guys marinate on these questions to sort of read through the chat and see if there's anything else that I should answer. I love that question. Sonia asked, so do I think it should be school policy or just guidelines? There's been a combination of the two. Over the last year, so I work with 3 schools directly right now in New York City. 2 of them I'm like really in the waters with. And these are schools that I've been helping to solidify their mission and vision around CS education. And one of the driving questions this year has been, how do we integrate AI education into the classroom? And so having conversations directly with the school leadership to think about some of these situations and to highlight some of the events that have happened, both not just in New York City, but like across the region or even in other states around unethical AI use by students. There's been cases where students have created deep fakes of other students and propagated those deep fakes, to cause harm. There's been instances where students have created deep fakes of vocals of teachers saying things and then releasing those deep fakes on the web, which has brought consequences to those teachers and investigations, and it's a waste of resources and time and money to have to then investigate and figure out that it was just a kid who didn't like his teacher, who created a deep fake of the teacher saying something crazy wild. So those things have happened, and having those conversations directly with school leadership has been pivotal. Another thing that I've also realized is most adults in these school buildings have not interacted with any AI. And that's shocking to me that it's almost 2025 and I have had conversations with people who have never, not even once, interacted with any sort of AI, not even ChatGPT. And so they're scared. There's a lot of fear. The adults in the building are bringing in some of that fear and uncertainty and that lack of confidence around putting AI or even talking about AI in their classrooms. And so I think the first step is to make sure that is not that it's defined, but that it's also not a scary thing. And for me, I've noticed that it starts with the leadership. And the leadership usually is the ones who inform the school policies and the guidelines around what are the expectations with technology use in the building, and then how does all of these other layers of tech, specifically with AI, how does that impact either instruction or the school culture? Let's see. Oh, that's scary, Diane. I did not know that. There's been discussions that already will be covered in code of conduct with cyberbullying. Yeah, so one of the schools that I work with, it's built into so they have a tech contract, which every student signs in August before the school year starts. And it has to be turned in by October because the expectation is that by October, everyone is on tech. And so, yeah, in that contract, there is language built in around cyberbullying. The plagiarism and all of that, I have not had those sorts of conversations yet, mostly because I've been working with the middle school and elementary world. I can totally see that being a situation in the upper grades. But yeah, I'd also be curious to know what is happening. But that's a really good talking point, which for me has been an area of concern over the last couple of months, is what are some of the policies that are either being crafted by universities or, what is out there that folks are leaning towards as a model for policies and changes to tackle plagiarism, cyberbullying, etc. My fear is the safety for students, not necessarily understanding the power of it. 100%. Yes, students may not understand the power they have when they have this AI tool in front of them. And I think there's this huge gap in knowledge between the adults, the teachers in the building, and the students who are already playing with AI, right? And so having conversations is the first step. Acknowledging, hey, there's this thing, it's called AI. Here's what it is. How are we using it? How should we use it? What should we not do with it, etc. I think that's really powerful. But I think navigating around it and not really addressing the fact and acknowledging that it's here, right? It's in the classroom. The kids are using it. I think that's the first step. And then it's hard to really answer the question of, a grand scheme of policies to put in place, et cetera, just because every school has a different culture. And right now, folks are still uneasy and haven't had the training to build that capacity to have those sorts of conversations. So I think speaking on my role as a community coach, my job over the next year or two is to really engage staff, faculty, teachers, everyone that is an adult in a school building, and expose them to some of these AI tools and educate folks on what are the impacts that this could have on students and having those conversations about the ethical and unethical use of AI. In Central America, so coffee beans. Yes. So actually, AI has been in use for farming and agriculture for a long time. I just recently learned that in Costa Rica, they use it to sort bananas, which is why I made the theme of this, bananas. And there are machines that are literally called sorting machines that identify fruit. And they sort of sort them based on size, color, markings, texture, weight, etc. And these are not humans that are doing these jobs anymore, right? They're just feeding tons of fruits into this machine, and the fruit is sorting it based on the data that it's being trained, which is fascinating. So that's what I have for our session. I try to make it so that we fit within the 45-minute time frame, but we still have about 4 minutes left over. So if there are any questions, please feel free to drop them in the chat. I would be more than happy to answer them. What I'm doing right now is I'm going to share the link to the presentation in the chat. So if folks would like to have access to this, they can. And then let me just make sure it's not private. Yeah, there you go. It was. Here we go. Okay. And let's go back here. And the link is in the chat. Feel free to reach out to me. I do have these activities as lesson plans. There are more resources. I would love to connect with the folks in the room. So feel free to hit me up and find me on LinkedIn. Again, my name is Edwin Jaquez, computer science coach, community coach at Cornell Tech here in New York City. Super, super excited to be a part of this. And thank you all so much for your engagement and participation today and for your curiosity. And I hope that this was a helpful and productive session for you.